Welcome, everybody. As you know, this is our winter quarterly meeting of the Silicon Valley Chapter IFC Designers Council. Thank you all for coming. Here's a quick review of the agenda that we'll be going through today. Which key was it? I want to thank our sponsors, Mentors sponsoring today. Nice lunch for us again. Thank you very much, Terry and Mentor. In April, Cadence will be sponsoring. We'll be meeting at their place in San Jose. In July, Altium is sponsoring. We're working on a location. I have a good source that I'm going to follow up on. I'll announce that when it happens. And then in October, we'll go over to Zukin, which is down the street here on the Milpitas-San Jose border. We are actively looking for speakers and topics. Those of you that used the Eventbrite to sign up, you saw a little questionnaire. I got several good ideas. One of the top ideas was high speed. So for next meeting, I'm trying to find somebody that will present the high speed topic for us. If you know somebody, please let me know and let me help reach out to them. Okay. So now, this is my favorite part where I give you food and get stuff in your mouth, and then we're going to go around the room and introduce yourselves. So you give us your name, your company, what tool you predominantly use, and this time let's say what types of design. Is it flex, RF, high speed, or whatever? As you know, I'm Bob McCrite. I work at Tesla. I use Altium, and I do a variety of different types of boards, mostly power. Right now I'm working on a really interesting flex project, which is challenging my brain. I did get an email from Jason Marsh, who's now at Apple. He says they're looking for a Flex DFM engineer, somebody with design and manufacturing experience with Flex. If you're interested in that or know somebody that's interested, contact me. I'll give you the link to their job site with all the details. With that, we'll start right here.
Yeah, I'm Lawrence Young. I'm a component engineer for Amazon at 126. I'm here just to get exposure, just to learn. I'm not a PC board designer. So I'd like to know more about footprints and how they affect the manufacturing process.
Okay. I'll be introducing Natasha here in just a little bit, so we'll go on by her.
I'm Jeff Gall in Western Digital. We primarily use Cadence tools, but we use a bit of everything. The design I'm working on right now is a multi-layer high-speed design, 25 gigabit.
Let's go over here.
I'm Marianne. I work for Qualcomm, and I'm a CAD librarian. We use Mentor and Cadence as well.
Okay.
My name is Vũ. I'm working at Qualcomm, and we are using the Cadence 7.2, and I'm doing the RF design and digital.
Mark Grimes, Qualcomm as well, doing with Cadence primarily and RF designs.
Okay.
John Woodford, also Qualcomm, Cadence, and doing RF design.
I'm Thomas Wong. I work for General America, and we use Cadence right now mainly, and I do the probe card PCB design.
Okay.
I'm Victor. I'm also from General America. I'm a new designer, but we use Cadence. High speed.
David Nguyen, I'm also from General America. We use primarily Cadence Allegro, but I'm familiar with Altium Designer as well. And we do mainly probe card designs, but I'm also familiar with ATE and Vernon designs as well.
Okay.
My name is Peters. I'm also from Jam. We use Allegro and CAD's layout, and we are doing probe card design, basically.
Okay.
John Lewis from Udamato, primarily doing high-speed, high-power designs using Altium.
Joe Tomasic, Lam Research, use Cadence, and I'm involved with high-speed, flex, power, kind of a mix of everything.
Vince Malinowski from Lam Research also. We use Cadence Allegro, and we do multiple different types of designs.
Let's jump back over there. Yeah.
Sean Powell. I'm from Form Factor. We primarily use Cadence, but we also use pads. And we currently have openings and we're expanding for engineers and PCB designers.
And what tool do you use?
We use Cadence and Mentor,
Okay.
primarily Cadence. And we do high-speed design, large probe cards, and our own IC design.
Sheeser with Shenmue America, a solder materials supplier.
Alex Green, Topcon America, we use OrCAD and pads for rigid flex sensor designs.
Okay. The gentleman here in the green sweater, you?
My name is Chuck Rush, and I manage a team of about 21 people at Amazon in Sunnyvale. We do support all of the Amazon devices, and so I'm going to put a plug in as well. We're hiring both here and for PCB layout engineering, and we do have a position for flex designer in Bellevue, Washington. So if anyone is interested, please see me after this.
Brian Truex, Amazon 1126 as well. Use Cadence, use
I'm from Amazon Lab 162. So I manage the PCB design team and we work on the kits.
Okay.
Lorenzo Cisneros, Marvell, we use Cadence. SB Digital, Signal.
Phil, same thing.
I'm John Zori, I'm a CID Plus and owner of Corporate Engineering Services, doing all kinds of various designs, independent contractor, and my tool is pads.
I'm Don Karen from Sierra International. I'm from Southern California, so I pretty much at the groups down there, but I do work up here. We have PCB manufacturing and chip scale manufacturing in Japan. Our design center uses Zuken, Mentor, and Cadence.
I'm David Shamsuddini. I'm an FAE for SierraConnect Group. You are building the PCB.
I'm Michael Now. I'm an application engineer here at Mentor Graphics. I support the PCB system tools.
Okay. And Terry?
Hi, I'm Terry Cleekant from Mentor. I specialize in the expedition design flow and Valor. And I too am a CID, so my background is mostly in digital analog mix, signal type boards, RF, and rigid flex. So we have a lot of technical talent in that area. I'm also part of the IPC group down in Orange County. So for those who are looking for people, if you want, collect my business card before you leave, because I know I have some people in that area that are looking for work, and maybe relocation would be appealing to them.
Rachel?
I'm Rachel. I'm from SierraConnect. Aside from manufacturing and assembling circuit boards, we also try to report and collect on all the events happening with PCB designers in Silicon Valley. So we're here to record this presentation and have it for you on the blog if you want to.
I'm Joel. I'm working with Rachel, part of the marketing team at SierraConnect, so enjoy the show.
Many of you guys have seen these guys around. They've been coming to our last several meetings and videotaping it and recording it. So we thank Sierra Circuits for providing that option for us. I want to, shout out to Gen America and Qualcomm for the biggest turnout of groups, of the teams. I'm really impressed with the turnout today. This is one of our biggest meetings we've had in a long time. Must be because of our speaker. Let's see. Oh, and by the way, from what I saw, heard, and from the survey that I took, Allegro seems to be the dominant tool in the area. So I want to skip this. I'll come right back to this. I want to again thank Mentor for sponsoring us today. I was going to give them. Michael, are you going to do the sponsor spotlight?
I was not told I was.
Oh, okay. All right. Well, we'll bring that up at the end. So let's go back to Natasha. You want to come on up and hook up your computer? I'm really impressed with Natasha here. She started a company up in San Francisco. It's called the EDA, or SNAP EDA. She graduated from the University of Toronto with a Bachelor's of Applied Science in Electrical Engineering. She's worked for a few companies in the semiconductor business. Also is a writer for a couple of magazines. And there's the rest of that stuff. So if you want to, so Natasha Baker, everybody. So you can go ahead and switch.
Oh, I can switch now, okay.
Now you can get a couple more mouthfuls.
All right, well, thank you guys so much for having me today. I'm really excited to get to speak to everyone and I can share the story of Snap EDA and kind of what we're doing and some of the common errors that we see in footprint design. So the bio actually that was on the previous screen is actually pretty interesting because basically one of the things that, the way I started Snap EDA was, it was back when I was working at National Instruments. I was doing some PCB design and I really wanted to design a board quickly, and I couldn't believe that I couldn't find the libraries that I needed to do that really quickly. And that's really why I started it. And yeah, I want to share a little bit more about kind of the motivation for that and how that all came about. So just as a quick overview of what I want to go through today, I'll give a quick intro into kind of my background, how I got started on this. And then kind of go into why libraries matter, why high quality libraries really matter. Discuss some of the common symbol and footprint errors that we see, both amongst people that are just getting started in PCB design and library creation, but also people that have been doing this a very long time and who still kind of slip up with these gotchas that are hard to catch. And then I'll go through the need for verification and some kind of tips on how your teams can implement processes for better verification, whether it's through checklists or other processes like that, and then some tools that can help you guys with library creation. And then yeah, if there's anything that you guys want to talk about, feel free to interrupt me. Happy to talk about anything you guys want to talk about as well. So by the end of the talk, I'm hoping that I can kind of convey, why high quality libraries matter, which I'm sure everyone in this room already understands being IPC designers. Common mistakes, again, made by newbies and also pros, and then tips and tricks to stay focused on building electronics and, not getting caught up in, library creation errors. So I know I was just introduced, but I also just wanted to kind of reiterate here a little bit about my background. So I founded Snap EDA, which is an online platform for electronic design content, symbols, footprints, 3D models. We've also recently introduced simulation models, and it's used by 1 million engineers each year all over the world. I've spent the past 12 years working on PCB design tools and libraries. So I started my career at National Instruments, and then basically, have been working on this company now for the past 5 years, and graduated from electrical and computer engineering out in Toronto, so I'm from Canada. So a lot of the time, people ask me, how did you get into this? Why are you so interested in libraries? And I wanted to share a little bit about this story. So this is actually a really simple circuit board that I made. It was like, the first circuit board that I'd ever made, and it was actually for marketing purposes. So I was working on circuit board design software at the time, and we wanted to create a cool demo for a trade show. And basically, we had this idea, which was, okay, let's show off all of the cool technology that there is in National Instruments, whether it's the data acquisition that they had, the circuit board design technology. And so we came up with this demo where we had the simple accelerometer board, just made from a reference design, and it hooked up to, basically we put it into a Wii steering wheel to replace the remote control. It hooked up to our computer that was running like a Nintendo emulator, and then through data acquisition, we collected the signals, and so basically at the trade show, people could control this Nintendo game. which was a really cool demo. So I thought, okay, this is going to be a super fast circuit board to make. I'll be able to make it really, really quickly. But as I was making the circuit board, I couldn't believe that the libraries that I needed that were in the reference design couldn't be found in my design tool. And so that's really, that was really kind of the moment where I realized that there's thousands of engineers all over the world that are kind of recreating these libraries over and over again. And why isn't there just one centralized database where engineers can go and get the symbols and footprints that they need, the simulation models, and use them in their designs? Now, back 5 years ago, things were very different because every company had their own standards for making libraries, and that's still the way I'm sure that it is today at a lot of the companies that you guys work with. But what we've seen recently is actually a shift in the industry where people are more prone to be using industry standards, or they might be using a library as a place to get started. And so that's kind of really where we're focused, but I'll go through that in just a minute. So while we're talking about libraries, let's just maybe go through kind of what I mean by libraries, because there's a lot of different definitions. So obviously when you're doing the circuit board design process, there's various stages in the design flow, whether you're doing the schematic capture, the simulation, the layout, or integrating with mechanical design. So today I want to focus on the schematic and the footprint. So we're not going to be focusing on kind of the other libraries, we're just going to be focusing on those ones in particular. So why do libraries matter? So the number one reason is obviously, to ensure proper manufacturing. If you have an improper pinout, that could obviously cause huge issues in your design. If a pad is off by even a small fraction of a millimeter, that could cause improper soldering. So really the number one reason is we want to ensure proper and reliable manufacturing. The second reason is for things like consistency and readability in your designs. And then the other one would also be to enable your CAD tool features. So for example, if you have your pins in your schematic symbol improperly defined, that's going to mean that things like electrical rule checking aren't going to work properly. They're going to flag errors where there aren't errors, or they won't flag errors where they should be errors. So having the libraries properly defined is very important for that. So, one of the things people ask sometimes is like, well, why are libraries so hard to get right? I think the number one reason is just there's so many details when it comes to creating symbols and footprints. For every pin, there's multiple things that need to be defined. For every part, a very similar thing. So it's a very extremely detail-oriented process. The second reason is within the industry, within the component industry, as everyone has probably seen, there's a lack of consistency when it comes to how data sheets are defined and how pin information is defined. And that makes it really difficult for engineers because every time you're looking at a data sheet, it's almost like you need to understand that component manufacturer's way of representing data. And so that leads to a lot of errors in the design process as well. The third is lack of standards or industry alignment. So it's great that IPC has standards around footprints. Obviously there's different versions of the standards. There's new standards being introduced, and that's great, but it doesn't cover everything. So you have, some standards like IEEE that will cover some symbol standards, but it doesn't necessarily cover things like, integrated circuits and how to position pins. And so a lot of the time, when you start looking at symbols, there's no standards for how integrated circuits are defined. And a lot of that falls back onto user preference or company standards. And then finally, I would also add that libraries probably don't get the most kind of glamour within the industry, within your company. I think a lot of the time, I personally think they're awesome, and I think that they're the backbone of what makes hardware great. And what enable engineers to build really good products. But when you look at the overall kind of, overall bigger picture, a lot of the time people are looking at this is the hardware that's being created, this is great, And libraries are sometimes an oversight for some companies, or people, they don't realize how much goes into high quality libraries. And so I know a lot of you guys all come from big companies that really care about libraries, but there's smaller companies that think of it as more of an afterthought. And so I think that's one of the other reasons why people really struggle to get this right. So I mentioned before standards, so obviously IPC. For footprints, there's the 7351B. There's also the 7351C that's being developed as well. And then on the symbol side, there's IEEE. So 315 is what we use for schematic symbols. But again, this kind of covers a portion of things. And even with this, a lot of the time, companies will choose to use their own standards. Also with things like, even silkscreen, right? There's not really standards in IPC around silkscreen. There's clearance standards, but when it comes to the width of the silkscreen and things like that, there's not really clear standards around that. And so that's where I think a lot of companies struggle to define and kind of maintain standards. So the other reason that this is a difficult problem for people to solve is just that the scope is massive. So there's hundreds of millions of electronic components out there. Again, there's not always standards for everything. There's infinite user preferences. Again, company-specific standards, application-specific requirements, frequently changing industry standards. And again, many, many details required for every single pin, pad and part.
Is it making it like an IC subliminal?
Yeah, that was one of our engineers. That was his creator. Yeah, good catch. I'm glad you caught that. He'll be really happy. So the other thing, before I kind of get into the more technical aspects, is I would say that PCB library standards, they invoke a lot of passion, which I love. And I think that there's so many opinions around how things should be done. And I'm not going to get into, hey, you need to have this many, this is how wide your silkscreen width should be. I'm not going to get into that. I'll let you guys decide, because especially when there's no standards, there's a lot of opinion. And I would say that, no one's right or wrong. It really I think the main thing is consistency. Obviously, if it doesn't manufacture properly, well, then it's wrong. But when it starts coming to, things like, okay, what should be the diameter of my pin 1 indicator? There are some standards around that, but deviations aren't really going to cause too much problem as long as you're consistent. So yeah, that's just how I want to preface the rest of the technical talk. What I want to talk about is some of the common errors we see. I'm not necessarily going to tell you guys, hey, this is how you should do things. So let's just start with the basics. And so maybe before we get started, has everyone here, I imagine the answer is yes, but has everyone here created like a symbol and footprint before in their careers? Has anyone not created a symbol and footprint? Okay, great. So let's kind of breeze through the basics then, but just as a recap, obviously pin mapping issues are the kind of the most basic mistake that I see people making. And that's just, this is something that even, experienced engineers can make errors on just because it's so detail oriented, especially when you start looking at parts that have hundreds of pins on them. It's just inevitable. So one of the things that we do is we have engineers checking every single pin mapping to make sure that there's no errors, just because it is such a human, it's just a manual process that's prone to human errors. Another very basic one, so pad dimension errors. And so again, if you're making the pads manually for custom pad shapes, it's obviously a very, very error-prone process as well. And so again, what we do on our team is we have everyone kind of verify really each aspect of the design process. And I'll chat about that in just a minute. The other one, this is a very common mistake for, amongst, I would say, newer engineers, which is having the silkscreen too close to exposed copper. That could obviously cause bad solder joints. And so this is something that I see all the time with new engineers, but I think most experienced engineers probably are very aware of this one. So the other one that we see often is, and this is on things like connectors, just wrong outline dimensions or misinterpretations of the component dimensions. So mistaking like a vertical header for a right angle header, and then causing a bad outline on the PCB. So this is the other one that we see pretty frequently as well. So now let's go into some of the kind of more, I guess, esoteric ones. This one is one that I see a lot with really experienced engineers, and this one is really easy to kind of do, because a lot of the time when you're looking at a data sheet, it's the top view of the component, but sometimes it'll be flipped and it'll be from the bottom view. Has anyone ever made this mistake before or seen this before? Okay.
I had a really good one where Linear Technologies actually has a part that numbers backwards compared to the standard.
Oh.
And
yes.
Fortunately, my CAD guy caught it. Yeah, most of them are numbered from the same corner all the time, but there are occasions where they don't.
Yeah, that's a really good one, and I'm gonna have to update this presentation with that one, because the pin sequence being reversed. We've
Right.
seen that before too.
Yeah.
So yeah. So yeah, this one, I have some friends that make medical devices, and just really experienced engineers. Previously were doing like in the aerospace industry, and he recently made this mistake, and it really burned him. So yeah. Yeah, so this one actually just happened. This one just happened on our team, to be 100% honest. And so what happened was, as you can see, the dimensions are a little complicated. And the way that they're dimensioned, it's a little bit misleading as to what it's referring to. And so you can see there on the left-hand side, that is how our team interpreted it, but the correct interpretation was on the right-hand side. And so, these are the types of details that are just so critical. And this is why having a process and having a process where another engineer is checking it and double checking the interpretation of the dimensions is so important. So, another one, wrong centroid. So for the pick and place machine to properly do its job, the centroid needs to be defined at the center of mass of the component. So this is one that we see a lot of people overlooking as well. Have you guys seen this before? Or?
No, sadly, our company still dimensions everything on pin 1.
Okay.
Even surface mount. It's horrible.
Oh. Is there a reason? Is it just like it's in the standards?
I'm sure it's legacy. I couldn't tell you.
Okay.
They won't change it. So.
And similarly, wrong component 0 orientation. So IPC defines, BU defines top left. I think that's changing in C. I believe it's changing in C. Have you guys seen that, or is anyone familiar? Is anyone familiar with the IPC, the new IPC 7351C? Or yeah, do you know if it's? I believe it's changing in C to the bottom left. So, just something to keep an eye on is that you might need to update your libraries pretty soon. And then this one here, this one is improper pin definitions. So this is something a lot of people overlook. They just overlook the fact that it is important to properly define the types of pins, whether it's a power pin, an input pin, an output pin, because otherwise your ERC is not gonna, your electrical rule checking is not gonna work properly. Okay, so now,
Quick question again. So you're saying in the latest and greatest C version, they've changed the origin from the upper right to the lower left?
So yeah, upper left to lower left. But I believe it's, I'd have to check, but I believe it's for certain types of components. That being said, the standard's not released yet. So so who knows, it might change still. Yep.
I don't think it's the origin, I think it's the orientation.
Yes.
The pin 1 orientation,
Yep.
how a component's displayed.
Yes.
what, a definition of a zero rotation,
Yes, exactly.
which is opposite from what it's been.
Yep.
Yeah, that could be a lot of rework. Okay,
Yep.
thank you.
Yep. Yeah, and again, again, that could probably change because the standard isn't out yet. So, you know, don't make any major decisions yet, but something to be aware of. Okay, so verifying libraries. So regardless of where you get a library, whether your team is making it, whether you're getting it from a component manufacturer, whether you're pulling it off a third-party website, it's so important to verify the library. We see this happening where, you know, people don't check libraries. They just assume that this is going to work in their design exactly how it is. But it's so important because, you know, first of all, again, it is a detailed-oriented process. Revisions of data sheets can change, and that can change elements that can affect your manufacturing. And it's just a good standard practice with something that is so detail-oriented. So does everyone verify their libraries here, like before they go to manufacturing? It's part of your DFM, your standard process, I guess, right? Okay. Just making sure here. And so, as you guys are verifying things, I imagine your team has some standard checklists that you'll go through. Would you say that that's typically how your team goes about it? Does anyone want to share maybe a little bit more about how they go about the verification process? Or is it just this list of checks that you're doing?
We have PCB travelers at Lamb that travel from the designer to the checker to the EE to the ME.
Mm-hmm.
And there's just items you check off, just make sure you've done your part.
Okay, awesome.
It helps.
Yeah.
But a lot of engineers don't want to fill them out, so it takes too much time, so we're trying to, it's hit and miss.
It is, yeah,
Some
it
do
is a challenge.
Some don't want to, so
Yeah.
some just want to trust the designer. I trust you, I sign it off. And they don't really even look at it, so.
Yeah, and we've seen a very similar thing where enforcement of the checklist is challenging, and it's something that you really need to watch and kind of enforce. So, yep.
We actually run a dual process on checking. Some library items don't require so much checking. If you're adding a new 0402 resistor, why run it around to everybody in the company and take 24 hours to get a brand new part entered into the library? And
Yep.
we just do an attributes and you know, our typical company requirements for the library check, and we will forego a fit check.
And that's assuming that you've already made an 0402 to those specific tolerances and dimensions.
Right.
Okay.
And then on a more complex one, that's got to run through a full, you know, verification cycle, which I call fill in the gaps. Get a physical sample and figure out if it fits.
Oh, interesting. Huh. Now, does everyone keep like company?
Gaps, fill the gaps.
That's a really good idea. I might ask you more about that after. Does everyone keep like a standard company library here, like a verified library? Does anyone not keep a company approved library here? Yeah?
We have so many business units and groups.
You must work at Amazon 126.
Yeah, so I've actually just moved into a new group last year, and I'm kind of starting again from scratch. So I'm actually running a relatively non-verified setup, but I use my CAD helpers to verify everything that I've done. And yeah. So
Okay.
And they run Valor over at the end. So.
Okay. Interesting.
So yeah, it's kind of just like this.
Okay. Awesome. Yeah. So yeah, I guess obviously the first step is just defining the process. Like, what is the process that's going to help you guys to ensure that when you do go to manufacturing, that you're going to have the trust that everything is going to be okay. So really the first step is just defining what are these checks that we want to do. The second step is verification. So what we do is we have a second engineer running through all the checks, and usually it's a subset of the initial checks. In some cases it's everything once again. And then finally, how can you introduce more automated verification? So you were saying that you use Valor, for example, which is an example of some automated verification that you can add in as well to further verify the components. So this is just an example of some, some checks that, some checks that you could do, or you could kind of define. So what we do on our team is we have checks for, we have two different lists for the creator and for the verifier, and a component doesn't get released into our library until we've gone through all the different checks. The other thing that we do on our team is every single week we look at, okay, what are the components that were created? What are the issues that the verifiers found in the libraries? We graph it out and we take a look at, okay, what are the most common issues? And then we think about how can we iterate on our checklists to make sure that those checks get added into our checklist, or to improve our process. So this is just an example of kind of some of the things that we've seen, our verifiers have seen, and we review this again every week to just think about how we can improve further. Yeah, and then finally, automation. So automation is your friend, especially when it comes to things that are error-prone. So both in terms of helping you create things and verify. So to give you an example of some of the verification that we do on our side, so this is actually some technology that we recently launched, but basically what we do is, because there are so many, when it comes to libraries, there's so much data and there's so many sources of error, we've created some automated verification that checks the industry standards, it checks industry practices, it checks manufacturer information, and it weighs it all together to determine whether or not the initial component data that we got was even right. So I'll give you a quick example of kind of how this has uncovered errors in our own process. So one simple example is we recently created a header that was supposed to have 18 pins, but it only had 9 in our database. And we were trying to understand, what's going on here? Why does it only have 9? It should have 18. And this was, by the way, this was a header that was automated by our team. And so what we realized was that when we had gotten the data from the component manufacturer, they had specified it as a 9-pin component, but with 2 rows. But in other cases, they specified it as an 18-pin component for other component categories. And so they had inconsistency in their own data in terms of how they defined the total number of pins. Sometimes they defined it as 9 by 2, sometimes they would define it as 18, if that makes sense. And so what we did is, what we now do is we reach out to, basically we have a bunch of APIs and we validate the data against, all the distributors, like what do they say is the correct pin count? And we weigh that data to flag errors in the component vendor data itself. So that's just a simple example. There's other things we do, like for example, in this example, if it's an SOIC footprint, we know it should have a certain pitch as per what an SOIC footprint should be, right? And so if it's wrong, again, we flag that and we let the user know, hey, this is probably not a good footprint to use. So that's kind of the way that we're looking at verification in both how we create things and then how we validate it.
Question.
Yep.
How do you take into account that different contract manufacturers have different requirements for footprints that are not in any way close to IEC standard?
Yeah, so it's a good question.
And they are your main supplier. They are your main focus because you design for their process.
Yeah. So have you?
There's a
So
conflict.
So I have a question for you. When you create PCBs, will you change the footprints based on the CMs that you're working with to manufacture it?
Yes, otherwise we get extremely long VFX reports.
So yeah, it's an interesting question, and I'm curious, to ask everyone here: does everyone change their footprints based on the CMs that they work with in general? No. And the reason Carrie.
Typically, it would be a new part number because if you're trying to distinguish to a new manufacturer different from something might already be in your library. So yes,
Yeah.
there would be different representations.
I think what he means though is more not component manufacturer, but the contract manufacturer that you manufacture your board with. So the same part, but with different.
They still have their own standards, right?
Yeah, so I guess it's an interesting question because it's one that's come up with me before as well. And I've chatted with some of the CMs who've said a lot of the CMs have some of the same equipment they'll typically buy the same machines for building boards. Actually, Sierra, I'd be curious to get Sierra's thoughts on this since they're here. But it's a great question. And what we do right now is we do everything to IPC standards. And the reason is because what we believe is that, so what we do is we save all the component dimensions before we generate the footprint. And that way, if in the future we wanted to add further output and support other standards, other density levels, we do nominal. But if we wanted to support other density levels or even specific company standards, we could do that dynamically because we save that raw component data and then we apply the transformation to export that to an IPC footprint. So our system is totally set up. If there were other standards we needed to comply to in the future, that we could do that. But right now, it's not something we do, and I think it's something I want to learn more about because based on my knowledge, there isn't usually a huge difference in machines that are used by the different CMs, but it's definitely out of my knowledge level. I'll need to look into that further. But I'd love to chat with you after if you'd be open to it. So.
I have another question regarding your verification. What if the same part might be, mounted horizontal and another is more of a vertical?
Yep.
Again, most of my customers would refer to it as the same part number. How
Yep.
does verification check if the proper one was used?
So I don't think our verification checker incorporates that right now, but what we typically do is we'll add the two different mounting styles, and we'll just put them on the same product page. But yeah, right now, I don't think that's in our check, but it's a good check to add.
That's actually one of probably the biggest library mistakes I see from a lot of connector companies where they'll build 3 different connectors. One's a vertical, one's a horizontal, and one's for the board that plugs into it. And if you make decals for all 3 of those and plug them in, one of those decals swaps all the pin numbers. In fact, I have components in my libraries where I have multiple components and multiple customers I have to deal with, and I have more than one customer with one exact part, and they have 3 different ways they want to number the part. 3
Yep.
different customers, but it's physically the same part.
Mm-hmm.
And if you followed the data sheet, the 2 wouldn't plug in together. So I've more than one time had to call a connector company and say, your vertical to vertical works fine. Plug in the 90-degree connector and you swap pin 1 with pin 96.
Okay, so yeah, actually before we I want to run through some quick tools, but before we do that, does anyone have like any other kind of library mistakes they want to share or things that they think that they've seen that maybe recently or anything else that we didn't cover here?
Probably one of the most common things I've seen is when you have a standard kind of part and it comes in like 15 different packages. And if you accidentally put the PW in instead of the DW, suddenly your part doesn't fit on the footprint anymore. It's really easy with all the different trailers to get that wrong.
Yeah, that's a great one, like the manufacturer code, because they could have multiple of the same, the exact same package, but maybe there's a wide version and narrow version.
And similarly with symbols, occasionally some of the different packages will actually not have the same pin numbering as the other versions of the package. And so then you start having to incorporate which package it is into the symbol as well. Whereas in the good old days, these parts were all exactly the same, whether they were dip or surface.
Right.
Have you found in the industry that the larger the company gets, the less library control there is?
Well,
I take that as a yes.
No, I think I've seen the opposite. Well, it's interesting because I think times are really changing. It used to be that you had to go through the dedicated librarian, and now we're seeing that people are, the librarians are just so overwhelmed because there's just so much stuff going on, and sometimes engineers just don't want to wait, so they go around it. But I would say that, I would say that smaller companies, they're so new to this. They haven't been burned as much, right? Or, I would say there's definitely more control, at least from what I see it bigger companies, but that is definitely changing. We have a lot of large companies that use our platform or that use our one of our services called Instacart to request models, and these are like massive space companies. And so like things are just shifting because I think it's just, it kind of depends on the industry that you're in, right? If you're in an industry where you know, you do have very, to your point, very, like you need to have very specific processes in manufacturing, then that's totally different. But if you're doing something where maybe you're prototyping or, you know, maybe you are doing a lower volume, then it's different and people are just like, they just want to be fast. They want to just create the design and do it quickly. So do you see that bigger companies have?
Bigger companies I've been working at, the less control they've ever had.
Really?
Right.
Is that a
Smaller
new thing?
companies
Like,
usually have a very good set, very specific at what they do. They don't vary too much from it. You get the big companies, they're acquiring this, doing this, moving that. This new facility, everybody's got their idea, you know?
and maybe there's like a sweet spot between like small companies who, you know, they're brand new, they haven't been burned, they haven't established all their processes. The mid-sized companies who, you know, they're not so overwhelmed and they're, you know, the company isn't so huge from all these mergers and acquisitions, and they can kind of have these really nice processes, and then the big ones that start expanding too much. I mean, that could be. Have you seen things change, like from 10 years ago?
Well, in big companies, sometimes aren't all one company. So like Lam Research, you got the Bevel group, the Etch group, the deposition, CSVG, controls, and so there's 5 different departments, but only 2 of them share one library. All the other ones have their unique libraries, or they send the boards out to a vendor to make, or a contract person, and they have their library. So.
Interesting, yeah.
Yeah, I think, I agree. We have a similar thing with HGST, Wilson Digital, and SanDisk. They all have their own legacy plans, and even within those, SanDisk is made from Smart and various other places, and they all have their own process. And, you know, if you get all the engineers in a room, don't make sure there's no weapons, because it's, you know, not going to work out nice. No one can agree that the processes cannot be merged. There's absolutely no way.
That's right. 10 engineers in a room to design a horse, you'll get a camel.
Great. Well, does anyone have anything, before I kind of go into a quick run through tools, does anyone want to add anything else to maybe things that they've seen on, maybe we can hear from the librarians. Is there anything that you guys would want to add, or?
One of the things that's helped us a lot is we added revisions to our footprints. So we added, until it's checked, it's Rev 0. And they have a third-party tool that will compare the board, footprints on the board to your library. So we get a report before you send it out to manufacturer to tell you this part is prototype, it's Rev 0. So it's a really good check. So we know if it's Rev 0, it hasn't been checked yet. So we really make sure we check all those and rev them to 1 before we go out for boards.
Yeah, that's a great idea. And also, do you guys put like the standards in the as well into the components, maybe that it was made with, or I guess Rev 0 is enough if you know what standards it was made with.
Yeah, we have a document that specifies all the different component types, and then we have a checklist that's based on those specifications. So that whoever checks it is not the one creating the part. So it works out pretty well.
That's awesome. Great. All right. So let's jump into some of the tools. So SnapEDA, that's obviously the company that I founded. We support Cadence, Mentor, Altium, various tools in the market. Has anyone heard of SnapEDA before? Just out of curiosity? Yeah? Okay. That's good to hear. We have this other product. It's free, called InstaBuild, to help you make symbols. It basically, it uses simple computer vision. You drag and drop over the pins. It automatically determines if a pin is an output or a power pin, and it will auto-generate the symbol. So that's something else you might want to try with. It's a beta feature that we have on the site. And one of the other things that we have on the website is if we don't have a symbol and footprint, all of our libraries are free. We make every single library free, but if we don't have one, you can request it and get it in 24 hours. And so you just click the button, request now, and then in 24 hours, you'll get an email saying, hey, the part's available, it's ready to download. And that's basically it. So just as a quick summary, libraries are necessary for reliable manufacturing, readability, ERC. Obviously implementing verification is very important, and other tools can help increase your productivity and efficiency as well. So does anyone have, and I wanted to say thank you to our component engineering team for helping me with this. And yeah, does anyone have any other questions at all?
How do you make money?
Yeah, so we make money by working with component manufacturers and also by licensing our symbols and footprints to distributor websites and vendor websites. So if you go on, for example, te.com or CUI, connector companies, there's a little plugin where you can download symbols and footprints. So we've made the symbols and footprints in collaboration with those companies. So yeah, those are the two ways. So if you go on our website, you'll see sometimes some sponsored components, but it's not like, we don't have banner ads or anything, but we have component recommendations that are marked as sponsored. So that, and then when people download symbols and footprints on other websites.
Any more questions for Natasha? I want to thank you very much for a great
Thank you.
That was great. Thank you.
Thank you.
Okay, so I'm going to take a picture. Might be in PCB Design Fabrication magazine. Never know. Can't promise you that. So let's jump back to, we're going to now step back, and Terry, you want to come up and do a sponsor spotlight?
Sure.
Thank you very much. Will the slides be available to share them?
The lovely V diagram. Anyone who's gone to school has seen a version or a number of versions of this. I called this up for one reason. For those who know Mentor, Mentor is, as someone else has mentioned, a collection of software packages. I'm going to briefly talk about the board design aspect of it, not the IC side, not the verification for tape out, etc. So when we take a look at our board design, we not only focus in on the PCB, we actually do multi-board and communicate with our cable and harness, so we can go all the way up to the very top of systems. And with the acquisition, yes, anyone heard about the acquisition? We were acquired by Siemens a couple of years ago. So with that marriage of Team Center and NX, that gives us more of this connection to mechanical and to the software where we can do our component requests. As you were talking about earlier, version control, which one should we be using for this job? Which one should we be using for that job? Example, I've got like a Mil-Aero account will have ground and air, and they have two different libraries. But to the librarian, it's one library, and they manage different requirements depending on the part. So that's the kind of things that Mentor brings to the table. And the last thing I'll show you is this is how it kind of development-wise goes for the board group. We have the board division. Valor division not only is the MPI, which most people will know as part of design verification, but it also has the shop floor information. When it comes to analysis of the board around thermal, there is the board thermal analysis, but there's also the actual cabinet, more of a mechanical analysis. We have cable and harness, we have Team Center, we have NX. So if you have any questions about what we do, feel free to give me a jingle, take a card. Most importantly, if there's any information that you need around PCB design, This is a conversation Bob and I have frequently. We want to make sure we get the information to you. This is vendor independent, so whether you're working with a Cadence, which I heard a good number are working with Cadence in the room, whether you're Zukin, OrCAD, Altium, Mentor, what do you need to know to be of value to your boss? We want to make sure you're getting that information. So if you have ideas, please let us know, and we'll make sure they're part of the IPC meetings. Okay? And that's all I got to say, Bob.
Thank you very much.
Thank you.
Big round of mentors.
Thank you.
I'll open the floor up. Anybody have any questions or comments? Okay.
Quick question.
Sure.
Design dual footprint or hybrid footprint. What is the basic check that you can assure that the footprint will actually allow the part to be soldered robustly?
Is that for Natasha? Or how about a librarian? Any librarians that want to answer that? How about a design service?
I know most of my customers would go as far as validating the board through to a manufacturing check, depending on who's manufacturing your design. Because again, the manufacturers are going to have different tolerances, not necessarily the same. So I think, again, it's just part of the process. I don't know specifically what tools they would use, but in most cases, my customers just give them the ODB++ output, export, and validate with that. Is that something that you do, or?
No, a lot of times operations are pulling their hair out because they can't find second source. So a lot of time when you have second source, they're not exactly one-to-one fit, they're about maybe 85% match, so you have the 15% difference, and that can cause solderability discrepancy. So the problem is manufacturability versus material availability. Kind of conflict too, so kind of tricky.
I
So
agree.
you win one side, you lose the other side. It's a constant balancing act.
So actually, that's a good question, Natasha. Do you have a compare to say this part over that part, what the differences are? Because by data sheet, it would be so close. You have to look for that detail.
So do you mean in terms of like one footprint over another in terms of being reliable for manufacturing, or?
Well, there might be 10 to 15% difference between the basic footprint. And let's see, if you design for the larger one, and then you put the smaller one, then you have excess solder pool that flows around, so
Right.
it can rotate and flop around. But if you design for a smaller one, then it doesn't have enough solder to accommodate larger footprint, so it's trade-off, so kind of
Right.
basically,
And
is there some kind of sanity check to see the halfway that I'm okay to compromise to be able to fit both without any problem?
well, I think it depends on like a lot of things, like the application, right? Because sometimes you want to oversize the lens, right? And that's why IPC has multiple density levels. So I think it depends, and I also think that there are equations in like the IPC standards for what those sizings should be, depending on the different density levels. But ultimately, that's also, I think it's changing in the latest standard, right? So I think that, I think that it can work in various conditions. And yeah, I think that you probably just need to, go through all the standard manufacturing tests. But yeah, and that's the reason why we use IPC, is that there are a lot of different ways of, there's a lot of different ways of sizing the lens. And for us, that's been at least the most standardized way of doing it right now. But again, I think it just really depends on the application.
So when you install, you have two different parts. You basically have two different bombs, so you have a variant of the board assembly.
No, they don't want to have two bombs, they want to have one bomb.
Well, then how do you call out the different parts that are being spec for the?
Well, they put on the same part number.
Alternates on the same.
Yeah,
That's just an
alternate, yeah,
alternate.
second source,
Alternates on the same
alternate.
part number.
Yeah, so that's the trick. They don't want to have separate part number. It's going to, what do you call it,
Okay, well,
expand the bomb tool too big.
So there's two different parts or two different footprints for one part?
It's a supposed the same footprint, but they're not exactly one-to-one. They're
What I'm
maybe,
saying is there any secret sources that
they're
are secret?
85% similar, different by about 15%.
Okay.
So the difference between the two will it adversely impact the manufacturing solderability of the process? Is it able to, is there some kind of tool or some kind of software that you can do a sanity check? You say this is okay without actually soldering, because when you
Right.
solder, it takes too much time.
Like drop test or something,
Yeah, I
but
mean-
in a simulated environment.
Yeah,
so you're
because
saying, like-
if you solder, you just talk about one part, but you talk about 50 different parts, each one got three sources. You know, it's gonna work yourself to death when you have to solder everything, right?
That's a really good question.
So can you simulate the soldering process without having actually?
Yeah, that's a really good question.
No, actually,
Yeah.
probably the fastest way to do a check would be to assume a 3D representation of the part. So even if you didn't bring in like a step model to review it, and just relied on the old IDF, it would create a three-dimensional box around that. But visually speaking, I think that's the only way you're gonna be able to see. And what won't be accurate is what happens when your pads go outside that package. Because sometimes package outline, the librarians make them smaller than where the pads actually end up. So it would only help you with that package. And it's an idea.
It would be interesting if there was some kind of software that could simulate it though, to your point, right?
Yeah.
Because then you could, yeah, it would be really tricky. But-
John has a comment?
Isn't there something that Valor does? Because I've gotten back DFM reports where it says not enough heel or toe fillet. Could you just do Valor against the two parts and see what it looks like?
If you have the assembly option in Valor, yes,
Yeah.
absolutely. That's how we do it.
Work with your assembly house and see what kind of compromise you can come up with them. Because they're the ones that gotta build it, right?
But if they can, at the point you gotta do is we have to tell they that we can't make one part to fit the they part that you want.
John?
Question for Natasha, how would you compare SnapEDA to PCB libraries?
So, really what we're doing is, we're providing basically just a database. It's kind of like, think of it like a search engine, where everything is ready to download. And so a lot of what we're doing is just making things, it's very different just because, yes, we do provide libraries, but we provide a lot of other kind of things around the libraries. So for example, you know, you can batch together an entire library of components. You can request parts through our site, you can build them, and it's all free. So I would say that the biggest difference is probably, we're just trying to make it such that you don't actually need to do the upfront work to enter in all the equations, that you can just drag and drop it into your design. So we focus on things like building plugins into different tools, like Altium, Eagle, for some other kind of tools that it's embedded inside. Whereas some of the other tools, it's more of like a calculator. And they're very useful, and they're very useful especially if you want to customize a lot. But where we're really going is how do we make it just really easy to download, drag and drop into your design, maybe save your preferences. I'd say that's probably the biggest difference, and then we have a bit of a community built around it as well. So yeah.
You know, you brought up a very good point though about the two different parts and everything. Has everybody been dealing with the same component availability issues there are right now? Oh my God, I'm buying an extra bottle of aspirin a month to deal with. Just dropping in and dropping out and changing of components or this component into life. Nobody ever sends out into life notifications anymore, you know, because it happens so darn fast. That's been the biggest problem about keeping up with libraries for me in the last year. It's just all the component unavailability issues. You know, 2 to 6 week lead times have now gone to 26.
Yeah.
If you're not a great big company and have bought a lot of parts, you find a lot of people trying to swap out parts after the PCB shows up. You know, we build 26 of them with this, but we'll build the other 50 with this. It's starting to become a real problem. I don't know how we as designers can solve this, but boy, I'll tell you, it's gonna become a problem soon.
Charge by the hour.
Write your congressman. Anything else? One more round of applause for Natasha coming. And also Terry and Michael from Minter. So next meeting should be in April. And where did I say it's going to be? Cadence. Okay, very good. Have a good day. Hopefully it's going to stay dry the rest of the day.